SLOs. The first, today's SLO, division of complex number. After this Zoom session, inshallah, you are able to understand and solve problem about division. Second SLO, absolute value or modulus of a complex number. You are familiar with absolute value or modulus of a function in 9th class, chapter number 5. You have an idea about absolute value or modulus of a complex number, and after this session you will able to solve problems about absolute value of a complex number. And before this, you know about and have an idea about modulus or absolute value in previous 9th class, chapter number 5. Third SLO, Argand diagram. Argand diagram actually another method to represent complex number graphically. Argand diagram, third SL. The fourth SLO today, Argand diagrams of product and division of complex numbers. So after this Zoom session lecture, you are able to solve or represent product of two complex numbers and division of complex numbers graphically. Okay. अब ये क्या है जवाब दीजिए. The first, today's topic, division of complex numbers. Now we are first of all discuss steps for dividing complex numbers. The first step for division of a complex number, first of all, calculate the conjugate of the denominator of the fraction. Mean you are given complex number in the form of a fraction numerator and denominator. So first of all, find the conjugate of the denominator. Then second step for the division, multiplying and dividing by the conjugate of the denominator. Multiplying and dividing by the conjugate of the denominator. Third step, after multiplying and dividing by the complex number denominator, यानी आप जब conjugate denominator के conjugate से multiply और divide करते हैं, then apply the algebraic identity. Third algebraic identity. As you know, a plus b into a minus b is equals to a square minus b square in the denominator. तो डिनोमिनेटर में जो आपके पास वैल्यूज आएंगी, आप उन्हें थर्ड एल्जेब्रिक आइडेंटिटी की मदद से सॉल्व करेंगे। देन आफ्टर सिंप्लीफिकेशन you will substitute the value of iota square is equals to -1। आप सिंप्लीफिकेशन के बाद iota square is equals to -1 सब्स्टिट्यूट करेंगे and at the end division of complex numbers you will separate the real part and imaginary part of the resultant complex number। mean real part and imaginary part आप separate करेंगे। real part in which iota is not involved and imaginary part in which iota is involved। Now students, we will discuss here question number 5, exercise 1.1, question number 5, exercise 1.1, page number 13। If you have books, open your book at page number 13। Now we will discuss question number 5, divide and simplify in the form of
Recording in progress.
a plus iota b। Now look, question number 5 part 3, question number 5 part 3, 3 minus iota under root 5 divided by 3 plus iota under root 5। This is the third part of question number 5। Second step, solution for this division: multiply and divide by the conjugate of denominator। As you know, look at the screen, the denominator is 3 plus iota under root 5 and the conjugate of 3 plus iota under root 5 is 3 minus. When we are taking conjugate of the denominator, you know the conjugate of the denominator is 3 minus iota under root 5। हम इसका साइन चेंज करेंगे डिनोमिनेटर। Now look students, multiplying and divide by 3 minus iota under root 5 and also divided by 3 minus iota under root 5. 3 minus iota under root 5 is the conjugate of 3 plus iota under root 5. In the next step, the values in the numerator both are multiplying with each other because of same values, 3 minus iota under root 5, 3 minus iota under root 5. We will write as a whole square 3 minus iota under root 5 whole square. And in the denominator 3 plus iota under root 5, 3 minus iota under root 5 in the form of multiplication. And now we will use third algebraic identity. First value same as first, second value iota under root 5 same as second value iota under root 5. One of the factor has sign plus, other one has minus. According to the third algebraic identity, a square minus b square 3 square minus iota under root 5 whole square. And the numerator 3 minus iota under root 5 whole square is equals to 3 square, first value square, minus 2ab twice into first value 3 into second value iota under root 5 plus square of second value iota under root 5 whole square. Now we will simplify, solve the square and third algebraic identity. Now 3 square is equals to 9. 2 3s are 6 multiplied by under root 5 iota. We will get minus 6 under root 5 iota plus iota under root 5 square is equals to 5 square cancel with square root and iota square. In the numerator 3 square 9 and iota under root 5 square is equals to 5 iota square. For further simplification, 9 minus 6 under root 5 iota plus 5 into minus 1. The value of iota square divided by 9 minus 5. The value of iota square minus 1. Now simplify 9 minus 6 under root 5 iota minus 5. In the denominator 9 minus into minus plus 9 plus 5 is 14. In the numerators, simplified value 4 minus 6 under root 5 iota. In the denominator 14. 9 plus 5, 14. And we will now take 2 as a common from the numerator values. 2 into 2 minus 3 under root 5 iota divided by 14. 2 cancelled out with 14. And we will get the final answer 2 minus 3 under root 5 iota divided by 7. At the end, we will separate the final answer into real and imaginary part. 2 divided by 7 is the real part and minus 3 under root 5 iota divided by 7 is the real imaginary part. Now students, this is the division. The next SLO topic, absolute value or modulus of a complex number, related to exercise 1.2. So the absolute value, for absolute value, we will suppose complex number z is equals to a plus iota b. Let z is equals to a plus iota b. We can write this complex number a comma b. First time, Jean Robert Argand write complex number as a comma b in a 2 coordinate system plus iota transformed into comma be a complex number. Now look, the absolute value or modulus of z complex number is denoted by absolute value of z. Student, the method to find out the absolute value of a complex number z is equals to a plus iota b. As you know, a is the real part and b is the imaginary part with iota. Now, absolute value of a complex number is equals to square root, under root, real part, whole square plus imaginary part whole square. if we have a complex number, z is equals to a plus iota b, the real part a, no, under root a square plus imaginary part b, b square. This is the value of absolute of a complex number. Method, square root, the square of real part plus square of imaginary part. And this is actually, there is no iota in the answer of absolute value of a complex number. So this is always a real number answer. Now look, an example, z is equals to minus 3 plus 2 iota. Students, you know very well the real part minus 3 and imaginary part 2. Now, by using the method of finding absolute valued function of a complex number, z is equals to under root minus 3 square, which is the real part square, plus 2 square, which is the imaginary part square, now is also equals to under root minus 3 square, 9, and 2 square, 4, 9 plus 4, 13. So under root 13 is the real answer, real number answer of a absolute valued function of a complex number. Students, for absolute value or modulus of a complex number, we will use another example from exercise 1.2, page number 21. So look at your book, page number 21. Question number 5, you are given two complex numbers. Z1 is equals to 1 minus 2 iota, first complex number. In question number 5, exercise 1.2, page number 21, second complex number, question number 5, Z2, Z2 is equals to 2 plus iota. Now students, we will solve an example for question number 5 part B, question number 5 part B, B part 2. यानी क्वेश्चन नंबर 5 पार्ट बी का पार्ट 2 है, फाइंड द एब्सोल्यूट वैल्यू ऑफ प्रोडक्ट ऑफ two complex numbers z1 and z2. Now everybody listen carefully. Solution of product of two complex numbers, absolute value of z1 and z2 is equals to absolute value, the value of z1 1 minus 2 iota, the value of z2 2 plus iota in the product form inside the absolute valued symbols. Now we will multiply 1 minus 2 iota and 2 plus iota with each other. Now look, first of all, 1 multiplied with 2 plus iota like as, and then minus 2 iota multiplied by plus 2 plus iota, the second complex number. This is actually distributive property of multiplication. Now 1 multiplied by 2 and 1 multiplied by plus iota, we will get iota. Now the product of 1 with 2 plus iota, we have 2 plus iota, and when minus 2 iota is multiplied by 2 plus iota, we will get minus 4 iota, and minus into plus minus 2 iota square. This is the actual product of two complex numbers z1 and z2. You can easily understand, and you are familiar with the product of two factors. So here we are multiplying two complex numbers. So absolute value of 2 plus iota minus 4 iota minus 2 iota square. Now we will substitute the value of iota square. Now look, 2 plus iota minus 4 iota are subtracting with each other. Minus 4 plus 1, we will get minus 3 iota, and minus 2, the value of iota square, minus 1. Now minus 2 multiplied by minus 1 become plus 2. So we will write this whole value as inside the absolute value 2 minus 3 iota plus 2. Now look student, 2 is a real number. This 2 is also a real number. Both are now added with each other. 2 plus 2, 4. And the complex number become 4, absolute value 4 minus 3 iota. Now students, the absolute value function formula is applied. Under root the square of real part 4 square minus the square of imaginary part minus 3 whole square. Now students, we have inside the square root 4 square plus minus 3 whole square. 4 square is 16 minus 3 square is 9, and you will get 16 plus 9 inside the square root. And the final answer for the absolute valued function under root 25. Simplify square root 25, you will get 5. 5 is your final answer for the absolute valued function of a complex number. Now students, a new horizon in complex number, new thing for you all of Argand diagram. Argand diagrams are actually discovered by first time in 1800 and nearly 8, first half of the 19th century, when Jean Robert Argand first time used complex number, their properties graphically. And Argand diagram is a way to plot complex numbers on a graph, treating in a 2D plane, treating them like vectors. Yani complex number on 2D plane, treating them like vectors. Now, the basic idea for Argand diagram, students, basic idea for Argand diagram, first of all, every complex number, as you know, like z is x plus iota y, this is a standard form of a complex number, has a real part x and an imaginary part y. Real part x in a complex number without iota, imaginary part y. Look students, on the Argand diagram, what happened? The x-axis is called the real axis and represents real part x. Before this, in the 9th class physics reference axis, yeah, graph paper in the previous classes, xy graph paper, the x-axis, as you know that x-axis, horizontal axis, or another name abscissa. But in complex plane, complex number, you will represent or called x-axis as the real axis. And as you know, y-axis, now you are clear to know that y-axis is called the imaginary axis and represent imaginary part y on y-axis. So in previous sections, you know that on a graph paper, y-axis, vertical axis, and ordinate. But here, y-axis in a complex plane is called the imaginary axis. Now, students, we consider an example. A complex number z is equals to 3 plus 4 iota gets plotted at the point 3, 4. Argand diagrams of product and division of complex numbers. Students, here we will discuss the product of two complex number and division of two complex number on a graph paper. Look, the first complex number z1 is equals to 4 plus 3 iota and second complex number z2 is equals to 2 minus 2 iota. Now the product you knows very well. The product of complex number, we will get 14 minus and comma minus 2. This is the product of two complex numbers z1 and z2. Look, z1, the real part 4, imaginary part 3. Look on x-axis 1, 2, 3, 4. In front of 4, the y-axis is 1, 2, 3. When we will draw or plot the point 3, 4 is the z1 like as, and z2, look, real part 2, imaginary part minus 2. So we will represent on graph paper on x-axis 1, 2. In front of this, y is also minus 2. So real part 2, imaginary part minus 2. On graph paper, this is z2. Now we will represent the product z1, z2 on graph paper like this. Real part is 14 and imaginary part minus 2. So you can find out the number 14 on x-axis, and in front of this y-axis is minus 2. Now this is the product of two complex numbers z1 and z2. So by this separately we can represent first of all z1 first complex number, then second complex number, and then product on the graph paper. Now students, again we will consider z1 and z2 two complex numbers 4 plus 6 iota and minus 2 iota. Then division z1 divided by z2, we will find the division z1 divided by z2, first complex number 4 plus 6 iota divided by minus 2 iota. And by the division we will get 4 divided by minus 2 iota, we will get this value, and 6 iota divided by minus 2 iota. By the process of multiplying and dividing by conjugate of a number, you will get the division minus 3 plus 2 iota. The result of the division of z1 divided by z2 minus 3 plus 2 iota. Now we will first of all represent in the division case z1 real part 1, 2, 3, 4, and imaginary part is 1, 2, 3, 4, 5, 6, and the z1 is the first complex number in the division case, and z2, look at this, z2 is the second complex number minus 2 iota. The value of x is 0 and value of y is minus 2. Now student, z1 and z2 are separately represented on graph paper to complex plane, and now the value of division of two complex number minus 3 plus 2 iota. Look, minus 3 the real part 1, 2, 3, and the value of imaginary part 2, 1, 2, the division of complex number we will represent on graph paper by this. These diagrams are actually known as Argand diagram.